collapsed without any disaster, man-made or natural. So it just collapsed. So it raised a lot of attention in the United States, how safe are our bridges. And they actually initiate some program to check all the bridges. And the Minneapolis bridge is actually in good condition, but it just collapsed one day. Yeah. So these are potential choke points that can cause quite a bit of delay. And I will focus on mainly on these kind of choke point disruption for the freight analysis. Okay, so here is the research framework. To do freight analysis, you basically need to have two types of input. One is the truck origin destination trip table. And this one is actually very difficult to get. Later on, I'll show you a method of how to estimate this truck OD trip table by using an existing database in the United States called the FAF, stand for Freight Analysis Framework. And this is probably the one that will have the most error. And Dr. Park talked about it in his talk about the significance of this truck OD table. And in the coffee break, I just talked to him and how did they actually get it. There's two ways. One is by commodity flow, and the other one is based on truck trips. And it depends on what kind of data that you have. You may either use either one or both of them. Even if you use both of them, it's still going to be a lot of errors. And what I will show today is one way of how to estimate using a commodity flow data provided by the Federal Highway Administration in the United States. And we actually have to make a lot of assumptions and also make use of a lot of other databases to actually estimate this. And then the other one is the transportation choke point. And this will depend on the scenario that you want to analyze. So in the case study, I will be using an earthquake scenario, a potential earthquake in Utah. But in Thailand, perhaps, earthquake may not be such a big problem, but flood is a problem. So you can change the choke point to a flood scenarios. And then in terms of the decision support tool, we develop our own decision support tool, and I will talk about that. And then how do we assess the vulnerability? Basically, we will have some measure, and I will talk about the two measures that we use to assess freight vulnerability. And all of this will be, you will be able to visualize in a GIS. And we will be using a case study for Utah. And then based on the case study, we can make some recommendations to the DOT. Okay, so this is the one that I was talking about, how to estimate a truck OD trip table from commodity flow database. And there's actually a number of steps that we have to carry out. And basically, the database that we are using is called FAF. So I have another slide for that. So this is the Freight Analysis Framework database, and this is an integrated database of national and statewide data on freight shipments, and is categorized by many different things like by origin and destination, by value, by weight, by mode of transport, distance shipped, ton miles of commodity shipped. So there's a lot of data in here. And the one that we're using is actually by value, by weight, and to estimate the truck OD. And basically is conducted like once in every 5 years, the same as in the Korea case. So the one that I'm using is 2002, and the 2007 is just released this year. So the first step is to extract the FAF commodity flow by weight, okay? And these are in terms of thousands of tons. And there are different modes, so like from the domestic module, water module, or border. And what we're interested in is mostly the domestic one. So we extract the domestic one using only the truck. Remember, there are many different modes, so we only extract the truck mode from this particular database, and we extract it for all the states, and then also we convert that to just for a given state, Utah. Okay. In the original FAF database, there are 114 domestic zones. And what we do is first we convert that to 49 state zones, okay? And this excludes Alaska and Hawaii, but we included Washington, D.C. as another state zone. So that's why there are 49 instead of 48. And then what we need to do is we have to estimate the flow for just one state, which is Utah. And to do this, we need to estimate 4 different types of truck commodity flow. And basically is I to I, which is within the origin, and the destination is within Utah. Okay? And then I to E and E to I, which is from Utah going outside of Utah, and then from outside of Utah coming in to Utah. And this we can obtain from the FAF commodity flow. The only one that we don't have is the traffic that are passing through Utah. So these are the E to E. So we have to develop a method of how to estimate the through trips. Okay, and the way that how we do it, so let me talk about the matrix first. So here, the internal Utah is just one zone. So the size of this matrix is just 1 to 1, okay? And then we have 48 other states. So the I to E is 1 to 48, and the E to I is 48 to 1. And the through trips is 48 to 48. So we need to estimate this first. Okay, and the way that we did is that we, look at all possible combination of state as the origin and destinations and do a traffic assignment to it. Okay, and then in this way, we will be able to capture the through trips. So basically, the methodology that we're using is a traffic assignment. So this is a standard step in the 4-step forecasting process, which is the last step. So you can use any software to do that. Then we run a sub-area analysis, okay? And to run the sub-area analysis, this 48 state got aggregated into 19 external zones. So these are the points that they go into Utah, okay? So we use a software called Transcat, and they will estimate these external stations within the software. So you don't need to define it, okay? So now our matrix is basically 20 by 20, okay? So what we need to do, the next step is to disaggregate this guy, because if you only have 1 point to represent the whole state, you're not going to get the truck trip, you're not going to represent the truck trip that well. So we have to disaggregate this guy. And the way how we do it is to disaggregate according to the county in Utah. So just like in Thailand, I guess there are how many provinces? 76 provinces? So you would disaggregate into 76 provinces. Is that right? 77. Okay. Does that include Los Angeles? Okay, so in Utah, there are 29 counties. So the Utah state originally was 1 to 1. So now it got disaggregated to 29 by 29. So basically we have 1 zone per county. Okay, so right now the final matrix size is basically 19 plus 18, 19 plus 29, so is 48. So the whole matrix is 48 by 48. And to do that, what we need to do is we actually need to use the database from the Utah Governor of Office to get the populations and also the employment. So using this database from the state of Utah, we're able to disaggregate according to the population and employment. Okay, and then we run that estimation. So for the base year, these are basically the number of trips per year. So in the base year 2002, the total is about 7 million trips, okay? And within the state of Utah is about half of it, okay? And then for the future year, 2035, the total number of trips, you can see that is more than double. Recall in the beginning, I showed you the increase is 150% increase for the whole United States. But for Utah, you can see that it's more than 150% increase. So it's higher than the national average. So Utah is concerned about this increase in terms of the truck traffic in the state. Okay, so that is still in commodity flow. So the next thing what we have to convert to is actually the truck trips. So up to step 5 is everything is still by commodity by weight, okay? And this step is to convert the commodity flows to the actual daily trucks trip made in Utah. So in order to do that, we have to use, again, 2 different databases. One is the VIAS data, and this basically gives you the payload. And basically in the US, when you enter a state, you have to go do what is called a port of entry, okay? And the truck has to be checked and also weighed. So there is a weighing motion, okay, to weigh how much weight is the truck. And basically what we did is to use the average weight, which is 20.6 tons per vehicle, to convert the commodity flow, okay? And then the previous slide showed you, which is an annual commodity flow trips. So we have to convert it to a daily trips. And according to the highway capacity manual, the total work days per year is 300. Okay, I don't know exactly how they come up with that number, but that was the number suggested by Highway Capacity Manual. So you can see that to do this procedure, we have to use many different databases, and we have to actually make a lot of assumptions, to do this. So I can tell you the accuracy is not very good. So this is the accuracy. So what we have to do is we have to validate this against the actual truck counts that the DOT collected. And the blue one is the estimated from the procedure, and the red one is the actual count. And you can see basically they are fairly good except in the metropolitan area. Because in the metropolitan area, there are many different alternative routes. But we just represent the whole county as one centroid. So here, there is a lot of errors. So one way to do that is that we have to disaggregate in the urban area, and also use some of the local freight activity that is collected by individual firm. So that is the part that we can actually improve the accuracy. And this is the same as in Korea, like interregional, you're using commodity flow, and within the urban area, you're actually using truck flow, right? So I think there is a need to actually integrate these 2 approaches, and we're actually thinking a way of how to do that by integrating both the commodity flow that we obtain from the national database, and also the truck count that we obtain from the state DOT. Okay, so now I'll talk about the decision support tool that we developed. And basically, this is the kind of like the framework. So I already talked about the FAF database to get the truck OD trip table. And then you also have the network, which is in GIS map. And here you have to define the choke points. So later on, I'll talk about a case study where we use the earthquake scenario to define the choke points. So later on, I'll talk about how to use another database to define these choke points. Okay, and the main part is the decision support tool here, and we use a different GIS. This one is called Map Window. The reason why we use this is that this is an open source, which means that it's free, you know, and there's no license problem. So if you develop this and then you give it to a DOT, they don't need to buy the ESRI license. You know, they can just use this one because there's no license fee. So that's one of the reasons why we're using the Map Window GIS, which is a freeware rather than a commercial package. But of course, you know, using a freeware, you also have to do a lot of work because not everything is available. And the way how we're going to evaluate the vulnerability, basically we will be using two measures. One is connectivity. Okay, what this means is that if certain bridges or road is disrupted, can I still go from point A to point B? Or what is the detour route? Okay, and the second one is the flow pattern. So this will make use of the truck OD trip table. So we will assess, okay, if there is a disruption, how does it change the flow pattern of the truck? Yeah. So these two are actually complementing each other. So this is just a snapshot of the decision support tool. So you can see that it's just like any commercial package. You have your menu bar here, you have your menu icons, you have your preview map here, and this is the different GIS layer, and this is the main display area. And over here on the right is the assessment panel, so you can do different analysis, like whether it's connectivity or freight flow pattern change. And as I said, the decision support tool has full functionality, so when you want to change some attribute of a link, like say for example, if you want this link to be a choke point, all you have to do is click on it and then a table will pop up, and then what you do is you go to this column and then you change from enable to disable, so which means that that link will not be available for the analysis. Okay, and then you just save it. So the input is actually quite user-friendly. Okay. And this is the assessment panel. So basically, there will be a number of steps, and what you have to do is just follow step by step. And you can also view, like say for example, you want to view a particular origin destination pair. What is the route? What is the detour route? You can also do that. So I'll show you that. So this is the case for the connectivity. Okay. So this is the origin, and this is the destination. Okay, so this is the before disruption. This is the location of the choke point. So when you run the connectivity assessment, then basically this will be the path to go from the origin to the destination. And then also it will tell you how many miles here. Okay, so now if you want to define this as a choke point, what you do is just click on the link and disable the link. And you run the analysis again, and you will see that right now the path is a little bit detour because it cannot use this link anymore. And it will show that the distance is actually increased. So you can see that what's the detour distance if that link is not available. Okay, and you can do that for for each individual OD pair, or you can do for a group. So later on, I'll show you as a group. And this is the freight flow pattern.